first principle, definition of derivative. Using definition of derivative, find the derivative of the following function. Or it's the same thing as what? Use derivative definition. Find the derivative of the following function. Of the following functions. F of x equals to 5. F of x equals to x. F of x equals to x squared. F of x equals to 2x plus 1. F of x equals to x to the power of 5 plus 1. F of x equals to x to the power of 5. F of x equals to x to the power of 3. F of x equals to x squared plus 2x. F of x equals to sine x, cos x, tan x, exponential x. Solution. To use derivative or definition of derivative to find the derivative of the following function. By first principle, f prime of x is equals to the limit h approach 0 of f of x plus h minus f of x over h. Is equals to derivative of 5, the limit h approach 0 of anywhere there is x, plug in x plus h. But in this case, there is no x in the function. 5 minus the original function. This is the same thing as the limit h approach 0 of 0 over h. The limit is equals to 0. So by definition, derivative of the function equals to 5 equals to 0. Note that for any constant function, the derivative is always 0. For any constant function, the derivative is always 0. F of x equals to x. To use first principle to find the derivative, f prime of x equals to x prime. The limit h approach 0 of the function, plug in x plus h where there is x plus h minus f of x is x over h. The limit h approach 0, x plus h minus x over h. Limit h approach 0 of h over h equals to x. This is the same thing as the limit h approach 0 of 1. The limit is going to be 1. The limit h approach 0 is equals to 1. So the derivative of the function is the same thing as 1. F of x equals to x squared. To use first principle to find the derivative, h approach 0 of x squared, x plus h squared minus the original function over h. This is the same thing as f prime of x equals to x square prime. F prime of x is equals to x square prime is equals to limit h approach 0 x plus h minus x square over h. Limit h approach 0 x square plus 2xh plus h square minus x square over h. This is the same thing as the limit h approach 0 of x square will go away with minus x square. Factor h out, 2x plus h over h. Factor h out, h will cancel h. The limit h approach 0 of 2x plus h. Limit of sum is sum of limit. Limit h approach 0 of 2x plus the limit h approach 0 of no h is going to be 2x. H approach 0 is going to be 0. This is 2x. The limit h approach 0 of x plus h square minus x square over h is equals to f prime of x, which is equals to 2x square. The derivative of a function f of x equals to x square is 2x. F of x equals to x to the power of 3. To use first principle to find the derivative, f prime of x is equals to x cubed limit h approach 0 of x plus h to the power of 3 minus the original function over h. This is the same thing as the limit h approach 0 x plus h x plus h x plus h minus x to the power of 3 over h. What of in a case where the function is given to be f of x equals to x to the power of 10? In this case, use binomial x plus h to the power of 10. This is going to be, in this term, is x plus h to the power of 3 when the function is x to the power of 3. When the function is x to the power of 10, here will be x plus h to the power of 10. Use binomial theorem of the summation of k start from 0 to 10. Then combination k, x to the power of 10 minus k, h to the power of k. In this case, x plus h to the power of 3 will be equals to summation of k start from 0 to 3. 3 combination k, x to the power of 3 minus k, h to the power of k. This is the same thing as 3 combination 0, x to the power of 3, h to the power of 0, which is just 1, plus 3 combination 1, x to the power of 2, x squared, h to the power of 1, plus 3 combination 2, x to the power of 1, h to the power of 2, plus 3 combination 3, x to the power of 0, which is just 1, h to the power of 3. 3 combination 0 is 1, x to the power of 3 plus 3 combination 1 is 3, x squared plus 3xh squared plus h to the power of 3. This is the expansion of x plus h to the power of 3. You can check my video on binomial theorem. So the f prime of x, the limit h approach 0 of x plus h to the power of 3 minus x to the power of 3 over h is now limit h approach 0 of x to the power of 3 plus 3x square h plus 3xh square plus h cube minus the original function over h. This is the same thing as the limit h approach 0 X cube will cancel X cube. This term there, H is common, factor H out. Factor H out, 3x squared plus 3xh plus h cube over h. Then h will cancel h. Any term with h, when h approach 0, the term will goes to 0. This term will also goes to 0. H will cancel h, and we are left with only this term. So the limit is going to be 3x squared. So f prime of x is equals to 3x squared, given the function f of x equals to x to the power of 3. F of x equals to 2x plus 1. To use first principle to find the derivative of the function, by definition, f prime is equals to the limit h approach 0 of f of x plus h minus f of x over h. F prime of x is equals to 2x plus 1 is the same thing. This is the same thing as the limit h approach 0 of anywhere there is x, plug in x plus h. 2 plus 1 minus the original function. The original function is 2x plus 1 h. This is the same thing as the limit h approach 0, 2x plus 1 minus 2x minus 1 over h. The limit h approach 0, 2x will cancel, it's minus 1. This is the same thing as 2h over h. 2x minus 2x, 1 minus 1. The limit h approach 0 of 2. The limit h approach 0 of 2 is equals to 2. Using the first principle, the derivative of the function 2x plus 1 is equals to 2. F of x equals to sine x. To use first principle to find the derivative, f prime of x is equals to sine x. This is the same thing as the limit h approach 0, sine, anywhere there is x, plug in x plus h minus the original function sine x over h. This is the same thing as the limit h approach 0, sine x cos h or cos plus sine h cos x or sinh minus sine x over h by trig. This is the same thing. Limit h approach 0, sine x cos minus sine x plus sinh cos x over h. Limit h approach 0, sine x is common, sine x cos minus 1 plus sinh cos x over h. There is no h here. Factor sine x acts. Limit h approach 0, cos minus 1 over h plus sinh cos x over. Limit of sum is sum of limit. Limit h approach 0 of sine x cos over h minus sine x plus limit h approach 0 of cos x sinh over h. The term without h, factor it out, sine x, the limit h approach 0 of cos h minus 1 over h plus cos x, limit h approach 0, sine h or sinh over h. This is the same thing as sine x multiplied by 0 plus cos x multiplied by 1. The limit h approach 0 of cos minus 1 over h is equals to 0. The limit h approach 0 sin over h is equals to 1. So this is equals to cos x. So f prime of x equals to sin x prime is equals to cos x by definition. F of x equals to cos x. To use definition to find the derivative, f prime of x is equals to cos x prime limit h approach 0 cos anywhere there is x, plug in x plus h minus the original function over h. Limit h approach 0 cos x cos minus sin sin x. Here is positive, here will be negative, minus the original function over h. Limit h approach 0 cos x cos minus cos x minus sin x over h. Limit of differences is differences of limit. Limit h approach 0 cos x cos minus cos x over h minus the limit h approach 0 sin x over h. Term without h, factor it out. Cos x, the limit h approach 0 cos minus 1 over h minus sin x limit h approach 0 sin over h. Cos x multiplied by 0 minus sin x multiplied by 1. This is equals to 1. This is equals to 0. This is minus sin. So f prime of x equals to the derivative of cos is equals to minus sin x. Given f of x equals to tan x, to use first principle to find the derivative, f prime of x equals to the derivative of tan x is limit h approach 0. Anywhere there is x, plug in x plus h minus tan x over h. Limit h approach 0. Tan x is sin x plus h over cos x plus h minus the original function sin x over cos x over h. What is this expression? Limit h approach 0 sin x cos plus cos x sin over cos x cos minus sin x sin x over cos x over h. Denominator sin x cos plus cos x sin cos x cos minus sin x sin minus sin x over cos x. This is cos x cos minus sin h cos x. cos x into sin x cos plus cos x sin minus sin x cos x cos minus sin x sin. This is the same thing as cos x sin x cos. Use this to open the bracket plus cos square x sin minus cos x cos sin x plus sin square x sin over cos x cos minus sin x sin. This time we go away with this term, left with cos square x sin plus sin square x sin over cos x cos minus sin x sin cos square x plus sin square x factor sin out over cos x cos minus sin x sin. Cos square x plus sin square x is equals to 1 from 3. So the numerator is only sin over cos x cos minus sin x sin. So f prime, the derivative of tan equals to the limit h approach 0 tan x plus h minus tan x over h. The numerator is now the limit h approach 0. Limit h approach 0. The numerator is now this sin over cos x cos minus sin x sin over h, and as the limit h approach 0. H approach 0 of sin h or sin over h multiplied by 1 over cos x multiplied by cos x cos minus sin x sin. This expression is of the form h over x over h over x divided by h over x multiplied by 1 over h over hx. So this expansion is of the form. This is the same thing as what? Limit of product is product of limit. The limit h approach 0 of this expression is 1. So the limit is now acting on limit h approach 0 of 1 over cos x cos minus sin x sin. Plug in any term with h, plug in 0. Cos 0 is 1, sin 0 is 0. So from here, 1 over cos x multiplied by 1 minus sin x multiplied by 0. This is equals to 1 over cos square x. 1 over cos x is equals to sec x. 1 over cos square x is going to be sec square x. So the derivative of the function tan x is equals to sec square x. The derivative of the function cos x using first principle is minus sine x. The derivative of the function sine x is equals to cos x. The derivative of the function exponential x is equals to exponential x. The derivative of the function x is equals to x prime, which is equals to 1. The derivative of the function x squared is equals to x squared prime is equals to 2x. The derivative of x to the power of 3 is equals to 3x squared. The derivative of any constant function is 0. That is all for this video. Thanks for watching. In the next video, I'm going to use first principle to find the derivative of the function 1 over x, the function square root of x, the function exponential x, the function x plus 1 to the power of 1 over 2, the function exponential x plus 1, 2 to the power of x, 2 to the power of x plus 1.